Thank you all for coming to the aerospace coffee chats here with the session today on geometry import and geometry cleanup. So I'm going to start off as a general summary here today, go through the import options, show how to load in different geometry representations, show how to repair geometry. So that will include stitching, creating new surfaces, and a few different types of topology repair. And then finally, a few other topics around geometry, such as mid-surfacing and defeaturing. So let's cover here. And I will get started with the geometry import options. So to import geometry, there's a few different ways to do it. One way is File up top left, and then Import Geometry. So that's one way. You can also just click this Open button. And whenever you go to all, or you can pick your geometry type, that's another quick way to do it. And then the final way is when you have a file browser open, just dragging and dropping your geometry or HyperMesh model into the browser window. So I have this, I'm going to click on it and drag and drop, and that would also open my geometry model. I'll wait a second to do that and load my model in. First, I will show how when you do load a model in, so let's say I go to my geometry type today that I'll test with, which is a JT file, click open, and then this geometry options dialog box opens. This, most people might just skip over real quick, not look at the options, but it can be very important depending on your use case. A few of the important options to cover, I'm going to show in the preferences, but just important to know, you can set the defaults for this options dialog based on your geometry type, and then you can also change it in the dialog when you open it each time. To show how to set the defaults, I'll go to File, Preferences, and then go down all the way to Topology. So this is where you can automatically set things for geometry import under CAD, import options. This is what I would recommend, is to probably set your import options depending on your use case. So for example, if you commonly use NX-CAD in your PLM system, then you would just need to set the NX default options for your best use case. But here you can set it as defaults to save yourself time in the future. Since I'm using JT today, I'll just go through those. There also are some common geometry options up top, so I'll talk through those first. One important one here, hierarchy as BOM only or parts. This will load in only the bill of materials and none of the actual geometry data if you click BOM only as the default. So that can be really good for if you're commonly loading in very large assemblies in an industrial setting. Then you can change that to your default, and you can always load in the geometry later, so really no harm done for doing BOM only. The other option is parts, which is just the usual method for loading in each part as a part into HyperMesh. You could also check single part only to load in your entire assembly structure as one HyperMesh part if you want to kind of flatten the whole part structure for some reason. And then another important part of the assembly structure is display representation. A lot of people don't know what this does, but it is a very quick way to visualize a geometry. So if it's the lightest weight geometry viewer we have. And you can always load in the CAD data later, but this will just load in a quick voxel or a voxel, a quick surface representation of your model, so you can visualize things for some quick referencing with other team members. A few other options that are really important here are for cleanup tolerance. This is set to automatic usually, but you may want to click manual depending on your kind of size of the geometry and units that you're importing. You may want to change this. So if you're working in meters, for example, and you keep the target units as CAD, then you may want to change this to a bit smaller of a value because it will automatically clean up some spots in your model that maybe are close together while HyperMesh is reading it, things like that. that brings us to the next important setting, which is the units that are loaded in. By default, it's set to the CAD units, and HyperMesh operates unitless. So if you're in millimeters, it will stay as millimeters when you import it. You may want to change, so if you know the geometry was made in IPS, you may want to change to millimeter, and you could do this by setting the target units here. Again, these can all be changed in the dialog box on a file load basis as well, but here is where you set the defaults. Finally, a few more options under the file-specific options. You can see that same as before, same as common are repeated here. So if you want to load different types of files different ways, you could do that. And then under PDM attributes is probably the other most important spot, where if you do have PDM data in your CAD files, you could automatically load and assign those values here. So probably the most important values that you would want imported are material names, IDs, and potentially part numbers, if you want to keep those the same in HyperMesh versus your CAD. So bigger organizations can save a lot of time by having these PDM names set and automatically loading that data all into HyperMesh when you import your CAD. Okay. So I will actually go and load my model this time, opening up my JT file. So going to JT, this is just using the usual load dialog. You see it pops up, and this time I'll click BOM only. Okay, so you see in my model browser, the only things that were loaded are parts and part assemblies. And here I have, one assembly with a bunch of parts here, nothing else under those parts. The next thing that you might want to do is load the representation. You can do this by right-clicking on a part or an assembly and going to representation, load from session. The representation loader dialog then pops up where you can click the display or CAD. So the same way, those options, you could just click display and load the display of a certain part. This part actually was just the spot. So I'll load the stringers here, go to representation, load from session, and I'm going to load just the display. So we can see how quick that is. Loading the display of a model much faster and easier to visualize than the full CAD. So again, for large assemblies is what it's made for. And you can see on the model browser here, or the part browser, that the representation column says display. And alternatively, we can do something like loading in the CAD for other parts. So I'll load the CAD for this part. And we show that this one actually has feature lines and the full CAD. So that's the difference for CAD versus display representations. Okay, now that we've covered geometry importing and geometry representations, I will then cover editing a geometry. So we'll start out with the topology repair piece here. So I'm going to load in this CAD. You see, it's a lot easier when you may only have certain parts you want to work on at certain times. You can just load those parts in and then isolate that part. So I'm just working on this part for now, and that makes things faster. Another thing I do want to show in the part browser before I leave it is you can right-click on columns and add some attributes. So these geometries already had the PID, material ID, and material names in the PDM CAD files. So I'm going to load those in and then move to the right, and you can see it shows those in the browser as well. So this table is fully customizable. You can even move the columns around to make it as easy as possible to shows the information you need. Okay, going into repairing this topology now. I will start by isolating and making it current. I already showed isolating, and I'll show everything again. So I have all my parts, click on it, and click just I to isolate. Nice little shortcut there. Then I'll make current by right-clicking, make current. What that does may not be relevant here, but it will create new entities in that part and geometry. So let's say we add a surface, things like that. It will make sure that all those new entities are in this part and component. Okay. So now we're going to fix this part up. A nice way to check your parts is first going down to this visualization option and switching to topology. So now we can see the coloring based on the type of feature lines. Red is entirely open feature lines. Green is connected with two surfaces, and then yellow, if we see any yellow, that would be three surfaces meeting, so a T connection. Right now, it looks like some of our parts and surfaces are not fully connected. We can switch to surfaces on the top left to select and hide a few just to see, maybe why these aren't connected. And we want to fix all these up so we have a fully enclosed solid that we can then mesh later. Another visualization option that could be helpful is turning on wireframe. You can make this global with the visualization option here and clicking wireframe. So it'll still show those edges in topology. You'll be able to see through everything to look in more detail. Okay, so the first thing we want to do when fixing this up is creating a surface patch. So down here, I think I'll create a surface. Surface patches can be created on the 2D ribbon, surfaces, and then the default is patch spline. You can click find and it will look around for where it might want to create those patches. Click the right dialog to switch to and from them. But I actually don't want to automatically patch any of these here. I'm going to manually patch this one down here and show how you can select each of the edges to form a fully enclosed solid, and then either click with the check mark on one of those edges or click the check here. So there we go. We patched that fillet there that was missing for some reason. Maybe you had an error on import, and we can patch any surface that way using the patch tool. The next will be the extend tool. So that's under surfaces as well, and extend. This is kind of very similar to extruding an edge, but there are different options while you use the extend tool. First, we'll click on that edge, and then some of these options here are important. Maintain edge angles, auto trim intersecting, and the last one being create as new. Create as new, turning on would make sure this feature line stays. Trim intersecting would be if this surface goes higher, it would trim that surface when you extrude to it. And the final maintain edge angles changes the direction that it extrudes at. So here I'm actually just going to drag to the other corner, and we see it didn't automatically put those together. So if we turn on the auto stitching, then you see it will actually stitch all those edges together automatically. So that's what that middle auto trim intersecting surfaces does. It both trims and stitches upon extending. Okay, so we fixed up that part. Everything looks green. The edges are connected, which is great. Next, we'll go to split and plane so that we can fix up this corner with overhanging edges here. All right, so split is actually in the topology ribbon. The split and the stitch tool is all combined, so it's all together, and I'll use the split tool here. We're going to be splitting these surfaces by plane. Okay, so it's always what are you splitting first, and then by something else. I'll quickly highlight all those surfaces. Got them. And now splitting by a plane, you see this kind of auto clicks onto the edges and points. Another tip there is if you click shift, it will go tangent to a surface. So there we go, splitting all of those by the plane of this surface. Check that, and now we have everything split there. And it'll be really easy now to just box select these, go to a better angle, and box select these and delete them. So I have surfaces as my selection, pick all those and delete. Now we can stitch a few of these edges and create surface patches again, very quick here. So it's a nice place to show the stitch tool, again, under the split stitch. and instead of split, just go to stitch. We'll be stitching the edges here, and we just want to stitch all these edges. You can actually, box select those two and just click run. And the stitch distance is one of the settings under the hamburger menu. So make sure the stitch distance isn't too high depending on your model size, so you aren't merging edges that shouldn't be merged, but I know these defaults would be good. Like it didn't stitch, so some of these are actually too far. So that means I need to go back, change my stitch distance to a bit higher, and then stitch there. And you see it got the extra edges now. As I mentioned, the final step will be just patching these holes with the patch spline tool. This time we can click find, and it should stitch those together. All right, a few more topology editing tools here. The last one for the bottom right will be the cross extend tool. So we can see that two surfaces actually need to be extended. We could do that in 2 steps, or we could use the cross extend tool. As it says, extend surfaces to meet each other at a tangent point. So just select both those surfaces. And here is the extend distance. So maybe we should quickly measure just to check how far we need to extend these. Looks like 1.61 is the longest extend. So I'll make sure to have that in my settings, change the distance to 2 and extend. You see it's a little faster. It auto extends in quick steps instead of having to extend both of those manually. Finally, we'll probably just stitch these together the same way we were previously with the topology stitch tool. Auto select all these, and we'll see how much this gets done. Looks like not all of them, but a solid chunk of these were fixed. Now, some of these are probably too far apart, so let's go look. This, for example, looks pretty close, but I think, let's see, we just split, stitch by a slightly higher amount here, going up to 0.4. We're just missing 1. And then we can show one more feature of the stitch tool by stitching points together and put that point up. 1 second. Actually going to skip over to the next part, going a bit over on time here. So I wanted to quickly show the quick edit tool. It's an easy way to edit your geometry and add feature lines as well as washer splits. So quickly switch to another part here. And I need to load these representations in, show that again. And I want to split this surface to add a washer. So quick edit tool is a good location to do that. Splitting interactive, I'll show briefly, has tangent and perpendicular snapping. So there's the tangent snap and then perpendicular there. That just adds feature lines, so it's an easy way to section off your geometry depending on where you want mesh lines to be. And then to show I'm going to go back a few steps here. I'll also show the quick edit washer split. So this can be done automatically with some of the geometry options, but easy way to do it manually is here. You can change and do the exact distance and the number of washer splits you want, something to add into your geometry before you mesh. The final type of geometry repair and defeaturing to cover is the defeaturing tools. I'm going to isolate this defeature part, and I have it already. Make it current as well to make sure the changes and new parts go into this And then I will go to the Topology Defeature tool. All right, so each of these tools is important, but it's nice to know that all of these actions can be done in batch. So it's good to maybe run a few test parts to see the settings you need for these features and get a good batch configuration ready so that you don't have to, take away fillets every time manually and things like that. So starting off with defeaturing, let's get rid of the fillets. And here we have 5 to 15 as the settings for the range of fillets to remove. You can click find and see, okay, we just have the top fillet that we're currently selected to remove. I'm going to increase this so we can also include the bottom. So going up to 50. And looks like this fillet's a little too high. So if we click remove all, that will remove the currently highlighted fillets. And it's an easy way to get rid of fillets that you don't want in your mesh in the future, things that really aren't necessary to simulate. The next defeaturing option that I want to cover is the hole defeaturing. This works very similarly when you select, you provide a minimum and maximum hole diameter. And again, you can click find to highlight those specific holes. Here we just want the small holes selected, so that's the correct option. And then again, remove all, we'll cut out all those holes. Another defeaturing option that's important is cuts and edges. So at certain points, you may have a part of your geometry that's not perfectly squared off that you want to be square to have a nice even mesh. Very small fillets on surfaces is a common location. So very easy just to select that line and click the check mark for it. So showing again, this is removing the chamfer from a surface, select the line and click. The final piece of defeaturing to show would be the batch defeaturing. So I'm actually going to undo all the defeaturing that I had there. So fillets, holes, and the cuts. And I'll check this parameter file. So if you go to batch, edit parameters, another place that you can access this is under topology and param/criteria. So this parameter file is for batch defeaturing. And then under all these features are the same type of settings for batch defeaturing. So you could do different hole sizes. Let's see. You can get rid of certain fillets, remove edge fillets below radius 9. Could get rid of certain flanges as well. So this has even more options than some of the default defeaturing that can all be done in batch. And going to the batch defeature tool, same place, defeature, batch, and we'll highlight those surfaces for auto cleanup. Here it was actually editing the geometry instead of totally defeaturing based on the default parameters. So if you change these parameter files, you can get to a batch defeaturing configuration that best suits your use case. So to summarize, this covers the import options for geometry, your geometry representations, whether you have visualization or the actual CAD loaded per part, editing geometry, including the surfaces tool, the split tool, and the patch or in the stitch tool. This covered quick editing as well as defeaturing. So that is the session today for geometry import and geometry repairing. Thank you all for attending.